Arduino Lesson 3 Analog Output plus RGB. In our previous lesson, Lesson 2, we learned about something called digital output. And what that means is that it's a type of output that either turns completely on or completely off. So high would mean on and low would mean off. If you think about it, it's kind of like a light switch. High, low. High, low, high, low. But let's say you don't want it to be just on and off. Maybe you want something in the middle. How do you do that? Well, today that's why we're going to be talking about something special called analog output. What is analog output, you might ask? Well, if digital output is like your light switch that goes on and off, your analog output is kind of like a dimmer. Your phone has a dimmer that adjusts the brightness, so does some modern light switches. You may be asking, why does it work like that? Well, in the case of digital output, we see there's only really two options. It communicates in binary, which is just 1 or 0. Only those two values alone, which means you cannot go in between. It will only be completely on or completely off. But for analog, it gives you the option to go to the middle because it goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to all the way up to 255, which means you can explore those middle values like 174 or 190. So you can play with those middle options, and it doesn't have to be completely on or completely off. It can be in the middle as well. Why am I telling you all this about digital and analog? Well, it's because it's time for us to get into the real part of the lesson, which is about the RGB LED. The RGB LED is like our normal LED, except it's like 3 LEDs in one. There's red, green, and blue. That's what RGB means. And so, let's get to know about our RGB LED. You may be used to a normal LED, which only has two prongs. One is the anode, the other one is the cathode. The anode going towards the plus, and the cathode going towards ground. So it's pretty easy to connect. The conventional flow goes up here and then down there. And then there's the LED's more ugly and complicated cousin, the RGB LED. Basically, it's very much the same concept. We see here there's a very long prong, and that very long prong would be the ground, and everything else would be R, G, and B. It's basically a minus, and everything else is plus. So it's very much the same concept. This here is a neat diagram of your RGB. Just review it and you'll be fine. Now that we've learned about everything necessary, let's do the exercises. Question 1 wants us to wire a circuit so that the RGB will flash red, then green, then blue. Before I start wiring the Arduino or programming or anything like that, I always start with a schematic because it helps you plan out what you want to do. So basically, I take pin 11, 9, and 5 all as outputs. And you may be asking, hey, aren't those numbers like digital pins, not analog? Well, maybe we'll talk about that in another video, but pins 9, 11, and 5, they're compatible with analog too. And basically, they'll all be my pluses, and I run them through our RGB LED. So it runs, we have 11 running through R, 9 running through green, 5 running through blue, and then there's a resistor, because I definitely do not want to be paying for an RGB LED. And then we have all that flowing towards the ground, and that completes the circuit. And our hopes are that the RGB LED will be functional. Following the schematic drawing, I've wired the Arduino, and this looks like a mess right now, so I'm just going to explain how I wired it. I started off with the RGB LED, and basically the prongs go, it's kind of backwards, so it's R, ground, GB, and all these resistors, they all correspond to one prong. So this prong has a resistor, the second one has a resistor, the ground doesn't need a resistor, but the last one has a resistor. So RGB are all resisted, and RGB, so like these three wires over here, they all connect to the corresponding pins 11, 9, and 5. So 11 is R, 9 is G, 5 is B. And there's resistors, and the ground prong, interestingly enough, connects to our ground wire. And ground wire, it goes to the ground, so it goes all the way around and connects to the back over here. So now we know how the logic works when we were wiring it. Now time to explain the code. Serial begin, pin mode. Like, we're just basically declaring all these pins as output, and the Arduino runs at a speed of 9600. So it's just by default. The important part of this code is the loop. Now, basically, pin 11, 9, 5 are basically, like we talked about, RGB, and question wants us to make one on, and then the other one on, and then the other one on. So then R will be on, G will be on, B will be on. So, and everything else will be off, while R, G, B each have their turn of turning on. So let's run this code and let's see red, green, and blue. This is the code. I am going to upload it, put it to the serial monitor, and let's see our Arduino. Oh wow, works just like that. Red, green, blue, red, green, blue, red, green, blue, RGB. Successful. Question 1 is done. Question 2 is also very easy, but instead of red, green, blue, it wants us to make it magenta, purple, orange, raspberry, magenta, purple, and then etc. And you may notice that we have analog numbers here as well. So the RGBs won't be completely on or off. It should be somewhere in the middle, so that way when the colors blend together, that's how we get these very different colors. And it's because of these colors blending and adjusting the brightness until we get those colors. So for question 2, you keep the wiring, but all you have to do is minorly adjust the code. So in question 1, we've been using digital, high and low, because we're just turning on the simple colors, RGB. We just want them to turn on and turn off. But to get these unique colors, you want it to blend a bit. Remember the 0 to 255? We gotta adjust with those brightness. So instead of digital, we want to use analog. So in this code for question 2, I've literally just copied and pasted. It's all exactly the same. And the only difference is that instead of digital, we're using analog, and instead of high and low, we've got numbers that we've been given from the question. All I did was copy them down, and we got these colors. So it's should be purple, it should be magenta, purple, and I don't remember the other two, but it should be in that order. That's basically how you make those colors. Enough of the talking and blabbering. In the Arduino, we should be able to see 4 different colors: magenta, purple, orange, and raspberry. So I'm gonna take my code for question 2, I'm gonna upload it, I'm gonna put it through the serial monitor, and let's look at our Arduino. It's not exactly the colors from the question, like purple, or maybe it is, yeah. I don't know. It doesn't actually look like a magenta, purple, orange, and raspberry from here. But maybe it's just a faulty LED, or maybe the analog values I've been given were wrong. But nevertheless, we have 4 different colors. Thank you for watching this video. In summary, basically now you know how to not only use RGB LED, but you can customize your own colors by using analog outputs. Once again, thank you for watching. Please like the smash button and subscribe. If this video gets 100 likes, I will post a video of this Arduino disappearing. I will do it. I will do it. 100 likes, boys and girls. 100 likes.